Thanks again, everyone, for joining us here today. Again, this is moving to managed airflow. My name is Chris Munns. I am currently the senior manager and lead of developer advocacy for serverless services here at AWS. Now, the service we're about to talk about today does not fall into the serverless family directly per se, but workflows is an area that my team just spent a lot of time on covering. And so I'm happy to be here presenting this one here to you today. I've been at AWS for just shy of a total of 9 years across a couple different positions. And for the last 4 years, been focusing my time and managing a team that is responsible for a lot of the serverless content that you'll typically see, as well as some content for products here, such as the one we're about to talk about today. And you'll find us in blog posts and tech talks, speaking at events like reInvent and summits and things like that. You can find me at munns@amazon.com or at Chris Munns on Twitter, and I am always happy to try to provide information and guidance and help you along the way. So why are we here today? So the agenda here is we're going to be focusing most of our time on Amazon managed workflows for Apache Airflow, MWAA for short, which is a newer service here at AWS, recently launched at the end of 2020. And now Airflow, or Apache Airflow, I should say, is an open source project that's been around for a number of years now. There's a lot to know and to learn about Airflow. And so really today we're going to be focusing on this new service that we have here at AWS. We won't really be getting a lot into the best practices of building what are called DAGS for Airflow, and we'll talk about this here a little bit later, the design and the use cases per se, and we're going to save that for a future tech talk. But today is really about kind of insofar as the MWAA product, what it is, how it works, how you go about setting it up, and how you go about actually working with that product. Now, again, Airflow, I mentioned, is an open source technology that's been around for a number of years. It finds itself used in a number of use cases. It's a fairly complex product. If you're familiar with it already yourself today, then you probably have a good grasp for just how powerful it is. You know, in terms of the primary use cases that we see customers using it for today, both the open source version and the managed open source version, is things like ETL workflows. So places where data scientists and data engineers need to take data, they need to pull that data through some sort of a workflow where it has to extract, transform, and then load it potentially into another location. And so we see that data then going on to feed things like AI and ML workflows. We also see companies using this for things like DevOps automation. So you can take Airflow and use it in responding to incidents, in deployment pipelines, in scaling infrastructure reactively. A bunch of different places with how Airflow can be used. Now, like also a lot of technologies like it, and in my mind, I think of things like Hadoop. Airflow has a number of components to it. So much like Hadoop, where Hadoop has different concepts of nodes and manager nodes and things like that, Airflow itself has a number of different components that power the overall kind of machinery of running your workflows. So there's concepts such as a scheduler, which sounds pretty straightforward. It's the component that is responsible for scheduling the work that's going to happen in response to the workflows that you're going to be running. There's the actual worker, which runs your code, your business logic, handles, again, those use cases, those ETL workflows, the various things that you might be doing from a DevOps or an AI ML type perspective. There's the web server, that is the kind of UI customer-facing interface that you would use to interface with your Airflow environment. And then there's a metadata database. And so this is a database that is tracking that work, that's tracking the workflow executions that have happened, that's tracking all sorts of information about the environment. And so typically, if you were managing a cluster or an environment that was running Airflow yourself, you would have to think about each of these four components, scaling them, updating them, patching them, making them highly available. And this can be quite a number of challenges on a couple fronts. So here at AWS, what we typically do when we think about opportunities for building new products is we're listening to customers. We're listening to your pain points. We're listening to things that you would like to see us do better. We're listening to the opportunities that we have to make your life easier. And if you've been a customer of AWS for any period of time and you're familiar with some more of our product stack, you'll find here that what we're about to talk about today has a lot of similarities to some other products. Things like Amazon RDS, Relational Database Service, Amazon EMR, Elastic MapReduce, our services for Elasticache, as well as things like our managed Kafka offering, a number of places where we have helped reduce some of the burdens that you have in managing and running infrastructure yourself. So what are some of the challenges that you see? And I would say these are the typical things that you would see anytime that you're going to run software yourself, right? These are those tasks that take all sorts of toil time, all sorts of research, all sorts of effort, and whether you have dedicated staff that take this on or it becomes an extra workload on top of, say, your developers or your data scientists or whoever might be using a tool like Airflow, these are activities that aren't necessarily benefiting, your bottom line or your customers or helping you get ahead. And so 5 key challenges, right? Setup. So again, we've already talked about how Airflow here has a minimum of 4 components to it. You have to deal with setup and configuration and making sure those things are all running the way they're supposed to run. There's scaling. So some of your workflows might require quite a lot of scale. There might be quite a number of tasks. You may have quite a lot of data that you have to process. So how are you going to think about how you scale and respond to that? Security. We always say here at AWS that security is our first priority. It's the thing that we spend the most amount of time thinking about. And I think, frankly, when we talk to customers who end up running technologies such as Airflow themselves, security isn't necessarily one of the foremost things that they think of. Right? It's not typically that you think of something as a workflow manager being a security vulnerability, potentially something that could be in scope for audits or compliance, but it often is. And so securing an environment like this is, potentially extra steps. Upgrades. So when you have these systems that are key and critical to your business, how are updates performed? How can you do that without impact? And then lastly, maintenance. So when there are issues, when there are things that need to change, how does that potentially impact what's running at any point in time? And how do you think about, again, minimizing the impact? Is it a Friday night maintenance window? Is it some sort of way that you think about shifting traffic around between different environments? These are all things that you spend a lot of time on that, again, are not core to your product. So again, very similar to what we've done with other product areas where it's really about helping to reduce the burden of these challenges on you. We got feedback about Airflow in particular, and that's what led to us back at the end of 2020 announcing Amazon Managed Workflows for Apache Airflow, or MWAA for short. And so this is a managed service offering for Apache Airflow that really simplifies your life. And we'll talk about the features and the capabilities here in a moment. Now, this is the product name here is a little long. And one of the things that we have, or one of the other products that we have here at AWS, which is called AWS Step Functions, is very similar to Airflow. A lot of similar concepts, a lot of similar capabilities, a lot of similar use cases. And so both of those products, this here, managed workflows for Apache Airflow, as well as step functions, provide some of the same capabilities. Again, Airflow is the same open source product that you might be already using today, that you could be running on premises in your own data centers or in other cloud providers, whereas Step Functions is a fully hosted serverless product that we have here at AWS. So there's no servers or infrastructure that you manage it. But now Airflow, again, is that open source product. And so for many of you, this could be an option that just really fits with what your business is trying to accomplish. So let's talk a little bit more about what MWAA does for you. And again, focusing initially on those first few areas or challenges, I should say, that customers are often looking to see made easier for them. The first area we'll cover is the setup. And so as I previously mentioned, again, one of the key things that we try to do with these managed services at AWS is remove the burden of setup and install and configuration that you would typically have if you were managing this infrastructure yourself. And so MWAA is no different. It's going to handle the setup and the creation of the resources and all of the good stuff that you would, again, be doing otherwise yourself without you having to do that. And it allows you to build a full-fledged environment, as we'll see here in a bit, that has all the same capabilities that you would have if you were managing this yourself. So it's the same open source software that you'd be running. Again, so you could run this on premises and have a cluster also running up on AWS or environment, I guess I should say. There's a number of ways that you could do this through the management console, or CLI, APIs, or AWS CloudFormation, and we'll see an example of CloudFormation here later that you can pick up and run with today. Another key benefit that we have is around scaling. So as we'll see here in the configuration options that we have for Airflow, scaling is something that is now built in. So this automatically is able to scale up based on the tasks that are in your workflows that you need to have executed. And this is not something that you have to think about going and provisioning hardware and getting more nodes or creating or launching new containers yourself or anything like that. Again, it's just built into the platform. Now, we use what's known as in Airflow as the Celery executor to run the tasks that are as part of your workflows. And all of these workflows run, actually all the infrastructures you'll see here that we have, with the exception of the database, runs on top of AWS Fargate for Amazon ECS. And so this is a containers offering that we have that is considered a fully managed containers offering that you don't have to do any cluster setup or management for yourself. And so again, all of this is just completely automated for you. This isn't something that you yourself have to think about and spend time on. Security, I mentioned earlier that security is a major focus for us here at AWS. It's no different with a product like MWAA. And so there's a number of things that are built in here. It's integrated across AWS's Identity and Access Management Service, IAM, for both Auth-N and Auth-Z components. So what does this mean? It means that for the users that want to access the cluster, or configure a cluster, or launch a cluster, or access the data for the cluster, you have really fine-grained controls for how they can do that. Whether it's configuring what databases are accessible or what data stores, configuring where the DAGs that you create can get uploaded, or changing aspects of the networking controls around your environment, all of that can be controlled with identity access and management, again, in a number of ways to meet your organization's needs. Now, Airflow runs inside of a virtual private cloud, or VPC, and I'll talk more in depth on this here in a moment, but what it means is that from a network perspective, you have a ton of great controls at your fingertips, a number of different ways that you can provide or restrict access at the networking layer. Now, your workers, when they run and fire up to do the work that you've created as part of your workflows, they get assigned an IAM, what's called execution role, that can have policies applied to it that grant or restrict access to certain AWS services. So again, this could be the ability to talk to certain data stores like DynamoDB, or to pull data in and out of S3. And so this deep integration across the platform should just, again, help simplify the work that's involved in you needing to get data in and out of data stores. And then all of the infrastructure, again, as we're going to see here, runs inside of the VPCs. The workers and scheduler in particular run inside of the VPC that you control. And so that, again, allows you to decide, do they have access maybe to resources that could exist through a direct connect tunnel or a VPN? Are they restricted to certain subnets inside of your VPC that maybe have certain data stores inside of them? That's all something that you yourself get to control. When it comes to upgrades, this is something that is built into the platform as well. So we have the ability to upgrade and patch the Airflow environment for you. Again, that is a transparent thing that you don't need to take an action on, as well as being able to recover from failures. And so this happens in a couple different ways. The metadata store that gets created for you is created in Amazon RDS, Relational Database Service. That has a number of capabilities that are enabled by default for failover, for snapshotting, backup and recovery in terms of if there is an instance level failure on that side. And then due to the auto-scaling capabilities of the workers, if you do have worker container instances that are running in Fargate or tasks that fail, Fargate automatically balances those back out for you and recovers them. And so you really do end up with an environment that can respond to failure, that can recover from failure, and again, without you ideally having to take any actions in order to overcome those challenges. And then lastly, maintenance. So as I talked about briefly here, some of the aspects around recovery and restarts from failure, that's something you don't have to think about. MWAA, like many of the products that we have here at AWS, is integrated with Amazon CloudWatch. So CloudWatch provides you capabilities around metrics and logs, and that's very much key for this product. Almost all of the components that are part of your environment generate both metrics and logs. And so you can control where those are delivered to and how they are accessed and who can access those. Now, multi-AZ or multi-availability zone, this is the concept that basically your infrastructure is running in more than one facility, as it were, behind the scenes. And so the availability zone concept is one of the core foundational aspects of high availability and fault tolerance in AWS. And so with MWAA, nothing different about that. This supports the concept around multi-AZ to allow you to have more resilient infrastructure. So kind of three things we'll dig into here a little bit with how MWAA works. You create an environment, you copy your DAGs and plugins and other information up to Amazon S3. And then from there, you access the Airflow UI, which you saw a screenshot of earlier. Now, that is the same UI that you would access if you were running Airflow yourself. And so you're using the same experience. Your end, say, data scientists or data engineers would have no different of an experience interfacing with this managed Airflow as they would for any Airflow that you yourself managed. Let's talk a little bit about the architecture and environment. This is a very busy visual diagram that references, I would say, a lot of the various capabilities that come built into MWAA. We see here kind of two sides of this architecture. One, which it says in the customer VPC, so that's a virtual private cloud that you would manage and control, where typically other infrastructure of yours would exist. And then there is a service VPC. So one of the things that we've done with MWA, based on learnings from running other managed products inside of AWS, is that oftentimes there are components of the infrastructure which are, let's say, maybe a little special, a little different, require slightly different, thoughts around care and protection. And what we've opted to do is actually to run some of them in a service VPC. So service VPC is managed and created by the service itself that's running. So both the database, the metadata store, and the Airflow web server do run in a service VPC. Now, these are single tenant resources. These are not shared with anyone else. Your data is not in the same environment as another customer's data. But it is that these are managed inside the service team's VPC. Now, both of these components here, the database and the Airflow web server, are, I would say, special in the context of Airflow, in that it's really important that they have the right access to the rest of your infrastructure, to other AWS resources, to each other, such that your Airflow environment can properly function. Both the scheduler and the workers can potentially tolerate failure because they talk to these systems, and given the way that Fargate works behind the scenes, it will recover their tasks and will pick up where your DAGs were previously functioning, or running through tasks, I should say. So in this situation, again, we do run some of those resources inside of the service team VPC. The other side of this is that those two resources really have no reason to talk to any other resources inside of your VPC, with the exception of, again, the workers and the scheduler. So, an important difference is there insofar as how this works. Now, you'll see at the bottom of this image a whole row of various different AWS services that exist. You see Amazon CloudWatch, which again is used for metrics and logging for your environment. Amazon Simple Storage Service, or S3, which is where your DAGs are stored, where plugins and requirements.txt files, which we'll talk about here shortly, are all stored. Amazon Simple Queue Service, or SQS, which is a service that's used in helping to queue up the work as part of your workflows. Amazon Elastic Container Registry, which is what Fargate is using to store the container images that contain your workflow workers and the scheduler. And then AWS Key Management Service, or KMS. And so KMS is used whether you have a customer managed key or you use the service team, the service default key, I should say, for handling the encryption of various bits of data inside of this environment. And now each of these need to be available to your infrastructure, and there's two different ways to make that happen, which I'll talk about here in a moment. Otherwise, what we see is Secrets Manager, we see some VPC endpoints, we see some public network access. So there's a bunch of concepts here that I would say is actually very well documented in the AWS documentation for MWAA and explaining what these components are and how you need to enable access to them. Again, one thing to be really clear is that the scheduling workers all run on Amazon ECS Fargate tasks. So these are not things that you yourself have to manage or take care of. You do want to think about, though, where they exist inside of your VPC, as well as some nuances potentially around things like subnet spacing, or address sizing, I guess I should say, around things like network ACLs and security group configurations. Some of that goes a bit beyond what it makes sense to cover in today's talk. But you will see links to the documentation later that does help explain all of that for you. Now, when it comes to AWS or Amazon VPC, I should say, virtual private cloud, this is, again, another area where we have a ton of content on, or we have a ton of talks like this on, a lot of documentation and best practices. What I want to convey, though, is kind of the basics of what you need to properly have a VPC configured for MWAA. And generally speaking, what we recommend is infrastructure or subnets, I should say, that are spanned across 2 different availability zones. And you need a mix of both public and private subnets. So we see here an example where we have an internet gateway. We then have 2 NAT gateways in the public subnet, and then we have our MWAA infrastructure running inside of the private subnet. Now, again, when you launch your MWAA environment, it's going to ask you for give me subnet A and subnet B, as it were. Now, we see here an example where you're using NAT gateway. What is that for? So again, if we go back to the previous 2 slides here, we see all of these services that exist kind of at the bottom of the slide here, kind of, of the arrows pointing into the customer VPC. These are all required services that MWA needs in order to make your environment work. And so in order to talk to them from inside of your VPC, you need some way of getting out to them. So one really straightforward, easy way is a NAT gateway. And so NAT gateway is a service that you provision into specific subnets. It creates instances then that get public IP addresses or external IPs. And then you would have your route tables inside of your VPC for your private subnets saying that default routes were the NAT gateway. Now, you do have to launch then a NAT gateway in the other AZ and then point the traffic or the default routes for the private subnets in that other AZ towards that NAT gateway. And again, this is kind of a topic that's a little bit beyond what it makes sense for us to get into too much today. The other option that you have is another component of our networking stack here at AWS, which is called AWS Private Link Service Endpoints. As the name might imply, what this allows you to do is to create private endpoints inside of your VPC that represent various service APIs. This way, you don't need to send traffic out through a NAT gateway and then an internet gateway out through what we would consider the public internet to those API interfaces. And so again, what you have the ability to do is, going back 2 slides here, represent inside of your VPC directly the API endpoints for the various other helper services or peer services, perhaps, that Airflow needs to communicate with. So again, just kind of 2 different ways to think about how you build and do this. There are different cost considerations with these. Both options provide capabilities around scaling based on workloads. Both of them have a number of different security concepts and constructs that could be involved with them. To me personally, the NAT gateway is the simplest way of doing it, requires the least amount of configuration. That said, for many organizations where they very tightly control or restrict what type of ES traffic can leave their network, the private links are that solution. They're going to keep that traffic that you don't want going out over to the in quotes, your public internet inside of your VPC to those other services. So again, this is just a quick run through of some of the networking concepts related to MWAA. There's a bunch more in the documentation, as well as, again, a number of places that you can go to find out more about VPC, networking best practices, configurations, and so forth. Let's talk a little bit more about actually working with MWAA. Again, there are some nuances to the managed version here of Airflow that are a little bit different from what you might be used to dealing with if you were previously running Airflow yourself. So I've used this term a couple times here, DAGS. This is a core concept in Airflow. It stands for directed, I'm totally gonna mess this up here, directed, aclitic, graphs. I'm pretty sure I said that wrong, and apologies for that. That's why I just use DAGS, the acronym, myself, because that middle word gets me here. But these are the unit of work and the structure for jobs that run in Airflow. And this is a concept of basically how in a workflow you have one task that leads to another. Again, this is the directed aspect, the graph representing the different aspect, the different components inside of your workflow. And again, this is a core Airflow concept, not something unique or specific to MWAA. Now, there are a couple things about how you work with MWAA and DAGs. So we're talking about the DAG definition files, plugins, requirements, and then configurations for your actual environment. Now, again, talking about how MWAA has direct integration with a number of AWS services. One of the key ones you end up working with quite a lot is Amazon S3, your simple storage service. Now, typically you would upload the DAGs or ship them to the environment through one of different ways, directly through the interface. With MWAA, we've made it, I think, a little bit easier while providing some more security controls for you. So you take your DAG files, and again, these can be just basic, Python files essentially that represent your workflows. Upload those directly to S3. From there, you configure your environment such that it points at the specific bucket and path for where your DAGs are to be found. And then your environment actually pulls your S3 bucket looking for new information about every 30 seconds. And so it should pretty quickly pick up any new data that's put in there. And then that becomes available for you inside of the Airflow web UI. And again, it shows up just like any other DAG would show up inside of that interface. So it's pretty much completely transparent to you. There's a number of reasons and benefits why this is a good idea. Separation of roles and responsibility. Again, S3 is a incredible service to its own that has incredibly high durability and availability, as well as scale. And so not having to think about managing that on your own environment or cluster is just going to help make your life easier. Now, another thing that we find that customers care a lot about is that Airflow has a really awesome, massive plugin ecosystem. And so that plugin ecosystem is supported here in MWAA. And you get the ability to pretty much use any plugin. I've been asking the product team, are there any major plugins that were really popular that people can't run? And they weren't able to give me an answer on that they said, yeah, this is a top 10 one and it causes a lot of problems. So, again, please do let us know if you run into issues, but generally speaking, this is not something where we've gotten a lot of feedback about that. Now, in terms of getting your plugins to Airflow, works very similar to the DAGs. So you would zip up a plugin directory. Now, the structure of this is covered in the documentation. It looks a bit like the example that you see here on the right-hand side of this slide. You upload that then directly to your Amazon S3 bucket for your environment. You then have to have the environment configured to know where that plugin's zip file should be expected. And then you need to tell it, what version it should expect, and it will go and grab and pull that into the environment. And then from there, it's made available to you, and then as well as being made available to your actual DAG code. And so then you can just use a normal Python import statement to import that plugin, again, based on the namespace of the directory structure like you see here. And we've got pretty good solid examples of this in the documentation. Similarly, we support the ability for you to include Python packages. Now, this is using the standard Python requirements.txt file that's going to pull in packages from providers for Python packages. And so, as you see here on the right here, and again, standard example, if you know Python, same kind of thing you'd be doing for Python code that might exist anywhere. And in this case, you just put the requirements.txt file directly into S3. It does not require to be zipped up. You need to tell then the environment what version of this file you want to use. It will then, in the environment, run the Python packager commands against this requirements.txt file, install all of those packages, and away you go. Now, there can at times be package conflicts or installation issues, versioning differences, all sorts of things that can go on with dependencies that are tricky. And so we make the logs for this available for you directly through the scheduler itself. And so the scheduler logs would have all of the output from the running of the Python packager install against requirements.txt. And so you can go and see, hey, is there a version problem? Are there any other bits of information that I need here? And again, this is going to show up when you update and change this file. Then you can just have your DAG code use the dependencies that you've included here. And lastly, when it comes to kind of overall configuration and the environment, and again, things that you're familiar with if you're an existing Airflow developer today, is that we support the same settings that you would typically see in Airflow config or airflow.cfg. Now, in the interface, this is available to you via the Amazon console, not the Airflow UI in this situation. And what you could do here is basically modify the essentially environment variables for any of the various type of configurations that you would for Airflow. Now, we have some of the most common that will autocomplete in here kind of as like a drop-down, but this does not mean that we do not support the others. You can just type them in. And again, for the version of Airflow that your environment is running, these should be available to you to use. And then again, pretty straightforward here, as you see in the screenshot below, and then those are saved for your environment. And the last thing I want to touch upon is that, going back to the topic around plugins, there's a lot of plugins in the community today that allow you to interface Airflow with various AWS services. It's about a dozen or so different services, I think, that have plugins. Some of the most popular ones are Amazon EMR, Elastic MapReduce, Amazon EKS, or Elastic Kubernetes Service, RDS, or Relational Database Store, Glue, Batch, DynamoDB, all the places where typically customers would store data, we need to pull data out of, we need to run or execute tasks as part of a workflow. Those work here, again, with Airflow, again, with the added benefit that your workers are given an execution role that you can directly program IAM into. So you don't have to think about shipping around, access ID and secret IDs yourself, or passing around any sort of credentials. That can all be directly integrated based on the role of the workers. Okay, awesome. Let's go ahead and see a brief demo of this, mostly again around how you set up a cluster or the, I should say, MWAA environment, and what it looks like to interface with that. Okay, so I've come over here now to the AWS documentation. You might be saying, why would you start a demo in the documentation? And what I want to point out here is that we have what I think is one of the best quick start tutorials for a service at AWS. Why? Because it includes a complete CloudFormation template that gives you everything that you need to be able to start running and exploring managed workflows for Apache Airflow. Now, if you come into the documentation here, if you were to go to docs.amazon.com/MWAA, you would see the user guide. If you click into the user guide and you click on Quick Start, that's where you will see this CloudFormation template. Now, this is a great template that gives you, again, a VPC and all of the bits that you need inside of the VPC. It sets up the MWAA environment for you. It sets up things like log levels. It sets up the S3 bucket. Gives you everything, again, that you need to get started with working with MWAA. Now, if you were to take this template and paste it into the CloudFormation Designer, and actually, real quick, for those who are not familiar with CloudFormation, CloudFormation is a service that allows you to represent AWS resources in a text-based format. In this case, in JSON or YAML. This is a YAML document example here. CloudFormation has a bunch of concepts with it, but the big thing to note is you can click this little button here in the corner that allows you to copy the template to a clipboard. You can also go and download the template from this link right here locally onto your hard drive. Once you've done that, you can go into the CloudFormation service, and you have a couple different options. Once you get there, you can say create new stack and pass the template into that. You can also view the stack inside of what's called the CloudFormation Designer. Now, the Designer is a great tool for helping you to visualize and understand what it is that is going on inside of a template, as well as design a CloudFormation stack yourself. And so, again, this document or this template being so full-featured just really makes this easy for you. We see here that we have a VPC resource. Inside of that VPC resource, we have a number of subnets. Depending on that subnet, we might have a NAT gateway. So we see NAT gateway 1, we see NAT gateway number 2. We also then have some private subnets, and then we have a bunch of other resources such as routes, the default routes inside of, sorry, I should say route tables, and then the routes that are inside of them. We also see in here things such as security groups. So a no ingress security group, another security group for some of the resources. And then down below here are things that are not represented inside of the VPC itself, but maybe components of it, such as elastic IP addresses, the actual MWAA environment, our internet gateway, some IAM policies, an S3 bucket, and an IAM role. And again, all of this is in that template file, so you can read and see what it does and learn a little bit more about some of the capabilities that exist inside of here. Now, what I've done is taken this template and gone through the new stack creation inside the console. And so this is a stack that I created using all of the defaults. I literally just click my way through this one without doing anything interesting or exciting. And what you end up with, again, is a working Airflow environment. Now, if I come in here to the resources, I will see, again, all of the stuff that we just saw represented in the Visual Designer. I see routes, I see an S3 bucket, I see various aspects of the infrastructure, I see the MWA environment, manage policies, and so forth. And so there's, again, all of the things that you need here to get started. Now, from this, I could click on the MWAA environment, or I can go to the MWAA console, which is what I've done here. And so this gives me the environment that I have created. And again, this is my example environment. I click on the name here and find out all sorts of information about this, including the link to the Airflow UI, including the S3 bucket that was created, if there was a plugins file or not. This did create a folder for me called DAGS, which would be the default for my DAG files. I see the networking information, so the VPC that's configured, security groups, the subnets, and again, this is a public network option. I see then the environment class. And so the environment class is the type of instance that I've configured here. I have a maximum worker count of 2. So again, because this is an example, this is a little limited in scale, just to help kind of simplify and make my life a little bit easier. And then down below in the monitoring tab, or in the monitoring section, I should say, of the console here, is all of the information about where I could find my logs, the log level that's been configured. And so by default, this is just set to info, and if the logs have been enabled or disabled. Now, I would always recommend that you enable logging, especially if you want to dig in, understand what's going on inside of a service such as this. And so again, by default, this is left on. You get to view any encryption information. So this is just using the default for the service. And then that's it. Some permissions, some tags, which I didn't end up configuring myself. And then if I click into the Airflow UI button, which I happen to have open already, what we'll see here is the standard Airflow console. So this is the Airflow console. Again, I do not currently have any DAGs that I have uploaded to S3, but if I did, they would be populated here within, again, 30 seconds to a minute after they have been updated. Similarly, I can go through and view information about users if I want to create specific users inside of this. I can browse things such as the jobs, the logs, task instances, stuff like that. There's the administration console. There's the docs that exist, and then some more about this environment. And again, all that I did was take the base template that's here in the quick start and pass that into CloudFormation per the instructions that are here. And again, what I end up with on the other side is this full environment. From there, what we previously just talked about, uploading your DAG files, uploading plugins, requirements.txt, potentially passing in configuration information. If we come back to this environment here, I can click on Edit, and this will allow me to modify some of the configurations. And these are all of the defaults. But if we come down to things, for example, such as the environment classes, so this is not a topic that we have covered just yet here, but the environment classes are an aspect of MWAA that are important to understand. But today we have 3 environment classes that are available to you. We have the MW1 small, medium, and large. And then you see the aligned amount of resources that exist for the scheduler, the worker, and the web server. And then you have the ability to increase the maximum worker count today up to 25. That is the hard limit that we have for the service right now. We can see that I can configure things such as the monitoring and metrics, which again were set up by default. And then down here is where I have the ability to configure the configuration options. So as we talked about earlier, there are a number of defaults that exist in here that I can modify, as well as being able to enter in any of the values that exist today or could exist in the airflow.cfg. Now, I'm not going to make any changes to this environment because it is all good for me. But again, from this point on, you would be able to start testing your workflows and beginning to integrate with them for, again, anything you have existing. We also do have in the documentation a couple of examples that you can follow that are further tutorials and code examples of working with different AWS services and covering things such as IAM and the different resources there. But beyond that, again, this is a standard Airflow environment. The same thing you would see if you were running Airflow yourself, again, with a little bit of an AWS spin to it. Awesome. And so again, quick demo that I just wanted to show you there of setting up and running the MWAA environment from the quick start. And I briefly mentioned that we didn't get a chance to talk yet about the environments and pricing and how that works. We covered just briefly there in the console how you saw. This is a screenshot from the pricing guide today. This is the pricing for the region in US East North Virginia, or US East 1, which you could follow or find the information for the region that you're doing this at the link or the QR code seen here. Now, again, the way that pricing works for MWAA is you pick a environment size, and the environment size brings with it a aligned amount of resources. So you see here for the scheduler, the worker, and the web server, a certain amount of virtual CPU. And then that lines essentially with what we consider recommended workflow capacity that you see off to the right side here now. Now, this is kind of an approximation, depending on the work that you're doing, that's going to, impact this. And then what you have the ability to do then is also based on the auto scaling that MWAA can do for you, is increase the number of workers. And again, these workers go away when there are no tasks that are outstanding, and then can be spun up when new DAGs are being executed. You do also pay for the metadata database storage, again, depending on the workflow of your cluster. Now, there are a couple of examples there on the pricing page, if you scroll down a little further, that breaks down how you might want to think about this and what the pricing looks like. But again, it's all there. Similar, again, to how many of the other services that we have here at AWS that require you to spin up essentially behind the scenes containers or instances, and then give you some amount of burst based on the work being done. So, in closing, we've had a pretty quick run through here today of MWAA, or Amazon Managed Workflows for Apache Airflow. And we talked about some of the challenges of running Airflow yourself, and really how MWAA was built to align to make those not be challenges for you. Again, this enables you to then have your developers, your data engineers, your DevOps engineers, your MLAI focused folks not be spending time on the tasks that you see here, not be spending time on managing infrastructure, but getting away from some of that undifferentiated heavy lifting and just being able to use the awesome powers of Apache Airflow without having to do that work. So again, from setup to scaling, again, security, some of the options that we saw here just briefly in the demo, and then upgrades and maintenance, high availability, multi-AZ, the failure recovery that comes from the workers and schedulers running as part of Fargate tasks. A bunch of good stuff here that, again, yourself and your team are not having to focus and spend time on. Now, we really just kind of barely cracked the top of the iceberg, I guess, here, cracked the cover on this one. There's a lot more that exists out there. As we saw, there's a quick start guide in the documentation. Off the landing page, you can also find a whole bunch about other capabilities and things that are, possible use cases that we see customers doing with MWAA. And the last thing, we do have a channel inside of the Apache Airflow Slack that's called #Airflow-AWS, where customers that are both just running Airflow themselves, so the open source version that they're running themselves, or the managed Airflow option that we have here, people trading tips and best practices and helping each other out. So encourage you to check out those resources. There's great robust communities here around Airflow and a lot of interesting things that customers are doing. I want to thank you again for joining me here today for this Tech Talk. Again, my name is Chris Munns. You can find me at munns@amazon.com or at Chris Munns on Twitter. Would love your feedback here after this session has ended and any questions that you might have that we can quickly address. Otherwise, thanks again for joining and hope to see you in a future Tech Talk real soon.